So one of the things I get quite often is just different, scenarios or examples of programs that customers are trying to work through, right? They'll send me an email or give me a call, send me over a print, and I got to kind of work through how I would process that job, that application, that challenge. So, I was thinking, I do this so often, why don't we just capture this content and get it up for you guys on YouTube so you can kind of see in some respects how my mind works, or anybody on the team with me, kind of how we work through a challenge and a problem. And quite often we're using my virtual machine or Train to kind of work through this scenario. So that's what we're going to do today. I was emailed from a good friend of mine this little challenge, this part, and he's just kind of trying to work through how he would handle this type of program. So what we're looking at here is this is going to be a common fixture plate. So they're going to have individual parts kind of arrayed over the fixture plate. And some of the challenges certainly are, what keeps me from having to redo the tool path for every single part, since it's an identical tool path. The way they wanted to kind of nest it on the fixture, the bottom pieces were actually a mirror image of the top pieces. So I kind of want to work through this example. We're not going to program to the exact specifics of the print. We're going to use this kind of as a baseline to show you guys how I would handle this. Now, this customer does specifically use shop floor programming with our ShopMill, so we're going to methodize this through ShopMill. But the process I'm going through would really be the same if I was to do it in G-code. So what am I going to do? How am I going to do it? Well, my first thought is I'm just going to create a simple little geometry just for his example, but I want to walk around and profile this part. And I'm going to treat this first location, this is going to be at my first part location, and then I'm going to kind of array it. So I'm going to make a sub. The sub is going to handle, in my case, I just want to profile it just to work out the mechanics of this program. So we're going to have a sub. We're going to shift a 0 to the center of this feature. I'm going to have the center of the part be 0. And then we're going to shift it around. So you'll get a chance to see how do we shift part zeros, recall up the sub. And then if I'm correct, I think what I'm going to try to do is then take this entire row that I've programmed and then mirror it to get it on the bottom. And if I'm right, we should have a pretty decent mechanism to kind of show how to handle this job without going through all the details of every feature on the part and whatnot. Okay, so let's slide this aside for a second and let's get in and use the program. So I happen to be in my virtual machine. This is a track machine that I use quite often. We actually have a 7 in our technology center. So I'm just going to use this as a simple example, but I really just want to get into the operate side. This is the HMI side, and create a program. So I'm going to go over to Program Manager. I'm just going to go, I'll do it in my main program area, and I'm going to create two things. I'm going to create a sub program. The sub program is going to be whatever kind of feature I want to machine, and then I'll do a main program, and that'll set up the structure for how I handle this sub. Okay, so first things first, I'm going to build the sub first. I'm going to do everything conversational. Now you might be thinking, why am I up in the part programs area if this is going to be a sub? I don't have to make it a formal subprogram. I can call any file from anything else. So in here, I'm just going to call mine sub1 just to give me something recognizable that this is the feature that I'm going to be calling up. You can name it anything you want. I am going to make a ShopMill program. So select ShopMill. And we are in and starting to edit the file. Now, one of the tricks I may do when I'm dealing with grabbing geometry from a sub scenario into a main is I will probably not use the graphics. I really don't have any need for the graphics right now. When I go to simulate, I'll just use wireframe, and that keeps me from resetting the workpiece blank if I do set it up in the main. So I could use it at some point. I am going to use, let's say, a simple G54 would be my fixture 0. All right, we're going to work on the table. This machine happens to support both a rotary axis and a table. In my case, I just want to work on the table, inch. Then I got my normal modal stuff, right? Where do I go when I'm done? That's my retract. How close do I get before I start feeding? Am I going to climb mill or conventional milling? And that'll be dependent on a given cycle. So we accept it, and now I want to just build a simple feature, right? So I want something that kind of looks like this part, right? So I'm just going to walk around a box, throw a couple chamfers in the lower corner. But first, I do want to make sure that the sub that I create, I have a known zero location. In my case, I'm just going to work dead center of the part. Would certainly make it the easiest to handle. So I'll draw a little contour. We'll go over to Contour Mill. I'm going to do a new contour. I'll call it my profile. All right. And now I'm going to just draw basic shapes. So again, keeping in mind that the center is 0, 0. So I'm going to start in the upper left-hand corner, and I'm just going to do basically a 2-inch square box, right? So I'm going to come over to +1. I started in the upper left, which was a -1, +1. I'm going to come down to -1. Let's put a little chamfer in there so it kind of looks like his part. I'm going to pull back, -1 and X, and we'll throw another little chamfer here. This way also I'll be able to kind of see if my mirroring works properly, because I need something that's non-symmetrical, right? So here's my 2 chamfers. When I want to close the contour, I can just expand over, hit close contour, brings it right back to the beginning, or I could have given a line up. But this is going to be our little feature, right? Something super simple, not looking for anything all that complex. A lot of times when I work through these scenarios, I'm not looking for a lot of complexity, because we're just trying to work through what would be the format and the structure of the job. Not so much did I get the profile programmed exactly right to what he's going to end up cutting. That's his job. I'm just telling him how I can build the program. Okay, so we accept our profile, give it a quick little path mill. I'm not going to get too elaborate here. I do want to grab some kind of a tool. What do I got? I've got a 1/2-inch end mill. Let's see, that may be a little big, but we can see if it's going to clip the other one. Some feed rates, again, just an example. So I'm just going to leave some default values in here. We're going to rough it, follow the direction of the path, top the part, how deep, I don't really care. Take it all in one shot. Right? I just want to get something that goes around the part. So I'll do a little lead in, and then I'll do a little lead out. So we'll see a little approach and retract, and then we'll go simulate it. Now, since there's no blank, I do want to set my simulation up for showing my path. So if you expand over, do show path, which happens to already be on. Okay, now I have some 0. Now that move, that's just coming over from wherever it thought the machine 0 was to the part 0. So the big thing we want to look at, obviously, is my simple profile, and that walks around. I can see my chamfer. So I have some kind of geometry to work with. So now we can call up this geometry and kind of work through the mechanics of what the main program is going to look like. So keeping in mind, the objective is going to be to be able to grab a sub and call it up in multiple positions, and in an array scenario that's not the same kind of pitch every time. And then additionally, I want to see if I can mirror it. And then that mechanism could be now used for all of these different part stagings. So next step would be building up the main. So let's go back out to my program manager. I am going to create a new program, still ShopMill, and this is going to be main for sub 1. Make it simple. Oops, sun 1. No, that's not good. All right. So we got our main for sub 1. So now again, we're going to continue on the other one. Actually, I may want to go back and kill the G54, because I don't even want to look at that when I jump into it. In the main program, I do want G54. I could put my blank here. Again, I just want to see the wireframe, so I'm okay. So I'm going to leave that all the same. All right. So we now have our header set up. So really the first step is, where is my 0 on my fixture? And then how do I shift that 0 to some new location? So if I look at my part, for simplicity's sake, I'm going to say that the middle of my fixture is my Y0. So I'll use his dimensions to give us something to kind of work from. But I'm going to have, just because of where all these dimension lines are coming from, I'm going to have that middle point to be my 0. This probably would not really be where the 0 of the fixture is. Looks like there's some kind of a hole here. So maybe that would be the original datum, and then I would work from there. But just to keep things simple for now, I'm going to use this point in space to be the 0 of my fixture. So when I cut the first feature, I got to shift my coordinates up in Y to that point, and then we're going to shift our coordinates over every time we call it up after the first feature. So how do I shift things around inside of ShopMill? Well, what we have under various is the transformations button. So transformations is going to allow me a bunch of different things, right? I can go into my work offset, load different work offsets here. I can go and do an offset shift, which is a transformation, which is what we are going to do. I can do rotations, scaling, mirroring, which we'll play around with a little bit to see if I can use the mirroring. So there's a lot of different ways I could kind of approach this scenario. Other things I can do with invariance, I can call it my sub. So we're going to use that in a second too. So again, I'm in various, I go to transformations, I go to offset. Now there's two ways to kind of shift things around. So I can do a new offset. So that's going to basically clear any previous shifts that had been done. And I'm going to then really move relative to the active work coordinate, which in my case is G54. Now I'm not moving in my X, so I could leave it blank or I could set it to 0. Either one would be the same. I am moving in the Y. If I look at the print real quick. On the side, I got 12.48, so I want to go half that, right? So I'm going to do 12.48 divided by 2, quick little math. So this would be the center of that feature where I'm expecting to cut the first part. So let me hit accept. And now we've had a coordinate shift. So now let's call up the sub. So to call up the sub, it was in the previous screen here, so I'm going to move back, jump over to sub program, and we're going to go to sub 1 wherever it's hiding. There it is. Say OK. OK. So this should be enough for me to be able to simulate that part. Probably going to want to still go in and kill that work coordinate in the sub. Let's see if it affects anything. So in my case, everything looks at 0. So let's get rid of that. Now what's cool with the sub, if I expand over on this event, I can actually open up the sub program. So now I can come in and get rid of the work coordinate. Okay, and for my purposes right now, what I'm looking to see, this can get closed. What I'm looking to see is I want to see that feature shifted up in space relative to wherever my coordinate 0 is. Okay, now this is an interesting message. When you do make any mods to the sub, especially with the sub having been programmed in ShopMill, it wants you to have simulated that subroutine before we let it be called up. So just reopen it. So I came into the sub right here and do a quick simulation of the sub. So we're just going to roll around wherever that sub is. Right, there's my little sub. And just by doing the simulation while I'm editing the sub, now when I go back to the main, I can click simulation. It should load up fine and simulate. So if you make any changes to that sub, just keep that in mind. You're going to have to redo it or resimulate it. Well, that's interesting. So in my case, it's shifting over this location, but doesn't look like it's shifted up. So is that a graphics thing? Let's see. I have a G54. I'm offsetting my coordinates up 6.24 in the Y. That should be good. And I should be executing. It may just be a simulation scenario. Let me get rid of my G54 values. So these are the little things that you might work through when trying to figure out if in fact it's working. So I'm going to leave my G54 alone. I'm going to switch it to 505 here. So at least this way I can see, I can use them for a previous, another job in case I want to use them or get back to them again. So let's just go to 505. I know there's no values in there. I'll make sure that's not skewing my simulation, because the goal is that I see the part shifted up. I may need to have, there we go. Yeah, so that would be my 0 location that I'm coming from now that I have no. So that looks about right. I would buy that. Okay. The other thing I could have done is put an initial feature of some form just to get kind of my baseline for graphics. You know, sometimes we'll update the graphics based on at least the 0, based on where I'm shifting my zeros around. So everything looks okay. I think I'm all right. Let's kind of continue on. Really where we'll see it is once we try to go to mirror it, if I'm not shifted properly. Okay, so we have the mechanism. So at this case, now I want to start shifting to my next feature. So it's really going to just be a matter of now going back over to transformations, going to offset. And now this is where I want to be careful, right? I have a 0 shift active, and I want to now incrementally move off of the previous 0 shift. So I don't want to do new, or I would have to relate everything back to G54. So as long as I do additive, I can look at my print and see I have a 3.5-inch distance between the parts. Okay, so all I have to do with additive is put the shift in the axis direction I want to do in it. So right now I should get the whole feature directly to the right of the previous one with a 3.5-inch distance between each of them. So call up your offset, then remember to call up your sub. So certainly I could go back to subroutine here, find my sub, or I could just copy the event down, keep repeating it. So let's go to simulate, see how that looks. And I like to simulate in stages as I kind of work through these processes. So there's 1, boom. So I got my 2. So that looks like that's going to work and at least allow me to call up some geometry, whatever it is, and then handle moving it around. Now in this case, if this was an array, I could do some interesting stuff. I could nest the shift inside the subroutine. That's possible. And then have it auto shift over. That's something we used to do a lot when we were, in older controls when we had to loop something. In this case, if I look at the part, I have a gap here, so it's not a consistent pitch. So I'm just going to do it the way I'm doing it now for all those parts. And I'll just do 4 just so we can get past the gap. So we could mark, copy a couple events, paste, paste. I know I want 4. I do have to update this shift. So since we're doing an additive, right? We're doing an additive. If I think about it here, right? I'm previously at 3.5. I now need to go to 8.6. So if I take 8.66 and subtract 3.5, this would be that distance. So that's where I'm going to come up with this number. So I want to do, print says 8.66 minus 3.5. So there's that new pitch. That's going to get me hopefully the 4th. The 5th, and keep in mind I'm always working because it's additive to my last 0 shift. I now have to subtract 866 from 1216. So 12.16 minus, and you can hit your equal sign and bring up a full calculator if you don't have room in the field. I'm doing it right in the field. And there it goes back to the 3.5-inch pitch. So that kind of verifies or validates that it's a constant pitch. So from here on out, I could just keep doing an additive shift of 3.5 and then just calling up the next sub. So for a right, we should have 4 features with a gap in between. And I don't know if that gap would work out to the 3.5, no idea. Haven't worked out the math. I'm going to say no because it would probably have been 7, right, if it was a constant. So that looks okay. I think everything looks straight. Doesn't look like it's drifting. If you had a scenario where maybe, depending on what you're doing, it looks like it's kind of drifting up or drifting at an angle in the Y, since I'm not calling out the Y, then set the Y to 0. Maybe it's using the last state of the Y location. This scenario, it does not. That's not a problem. But I have run into scenarios where maybe I'm calling up like a pocket or something and I'm looping that. Um, you might need to make sure you give it both the X and Y coordinates for the center. That could happen. Okay, so we have this run of parts, right? Run of profiles. So handle in my top. So how do I get it down to the bottom? Now, for sure, I could come down here. I could set a 0 there, and I could take this feature and rotate about my coordinate system 180 degrees. And then start moving around. But I would have to do it with an additional rotation. So that is one way I could approach this. And I was originally thinking about that. But I'd like to try to do it with a mirror first. So with the mirror, I'm going to have to do a couple things. Not only am I going to have to give the system a mirror and telling it, what axis I'm kind of mirroring about, but I'm also going to have to figure out a way to call up everything that happened up here and do it again. Kind of labels to say, hey, what am I trying to repeat? What am I trying to do over? So what I'm going to do is I'm going to insert a label between my header and my first offset because I need it to repeat that one again. And I'm going to go to various. You do a lot in various in here. I'm going to expand my vertical keys till I see the repeat program field. And what this allows me to do, for those of you that maybe are coming from the G-code world, you're creating a label. And we call it a mark in conversational, but really it's effectively a label, how we would do it in G-code. So when I hit set mark, I just need a unique label. So it comes up with mark. I like to leave mark, so I do mark 1 and mark 2. Just make sure you don't use the same label or mark term twice in the same program, because then it wouldn't know where to jump to. But this is just a jump to point. It's just saying, hey, at some point I'm going to go to this label, mark 1, and I want to grab what's between mark 1 and, in my case, mark 2. So now we have a label. Now I don't want to call it up right now to do the repeat program because it would just go over top of itself. So I need to add in the mirror, right? So we're going to go back a couple screens, go back to transformation, and jump over to the mirror event. Now mirroring always goofs me up because if I would look at this part and say, okay, well, what am I mirroring? I'm mirroring about my x-axis, right? There's my x. But for us, it's not the axis I'm mirroring about, it's the axis direction I'm mirroring in. So this is actually a newer additive. I'm going to set this to new. This way it'll clear any previous zeros that have been set, but I may run into a problem with my first new. So that's something to kind of keep in mind. So I hit accept. I have now a mirror command in. So now I want to just call up everything. And that's how I'm going to use this repeat program function that I got to, right? So everything's going to be, really everything in this program we're doing is under various. So I go to repeat program. We go to click repeat program, and this allows me to call up the two markers. So that's where I need the unique labels. Mark 1 and Mark 2, I'm only doing it once. I hit accept. So let us see if this is going to work, and I think it's going to bomb. But we're going to find out. And then I'll explain to you why it didn't work, if I'm correct. So here's my first one. Okay, everything looks good. So I'm expecting it to be down here. Let's see where the tool goes. Yeah, see how it's walking right over top of itself? So the loop is happening, but the positioning of the new feature did not happen. So why? Well, one of the things when you play around with these types of transformations, it's what we call transformations, is the behavior of this whole new and additive. So as I mentioned earlier, when I set something to new, it cancels all previous transformations and really sets my zero back to my G54. Well, the new not only would affect offset transformations or linear transformations, but also affects rotary transformations, right? Everything, when I look at the transformation area, let's go back to it. So all of these kind of happen at the same place and time. So a new offset would not only cancel previous offsets, it'll also cancel rotation, scaling, mirroring. So that's where you want to be careful. So my gut is it's the fact that this is a new. Because if you think about it, when I'm down here, I set a new mirror, and then I jump back up and I have another new, which canceled that mirror. So this would not hurt me to be an additive because in this scenario, I have both positions. It's working off the G54. So if I know I needed to previously cancel, maybe I would insert another work coordinate, in my case 505, right? But maybe I would insert another work coordinate here or something just be above it. So just be aware of that kind of dependency, that interdependency of new or additive. What is additive? Think of it like incremental, right? It's not canceling my previous shift, it's adding on top of my previous shift. So let's simulate it. Let's see if I'm right. I think I am. All right, so we got our first four. I certainly could speed up simulation if I wanted, but I really want to get a chance to see what it's doing down below. Aha! And there we go. So my zero shift looked like it was fine. You see how we bump the zero down here as we just move around graphics. But there would be my pitch of my 12 and change. Now, one of the downfalls when you start using mirror is the machining path or machining direction because everything's mirrored. So what is conventionally milling up top, right? If you look at the top, I'm going around clockwise around an outside profile. So I'm conventionally or conversationally or climb milling, not conventionally, climb milling, excuse me. But now in the bottom, I'm conventional milling, right? Now I'm going counterclockwise. So that's not an optimal cutting condition. So this is one of the drawbacks when you work with mirror. Now, one of the things I could do is I could invert this cut direction. But where a lot of people that do know our control would think I'd have to fix this would be in the header, would be with this machining sense down cut, up cut. This has effect on pocketing and different can cycles, has no effect on the contour milling cycle. So your contour milling cycle direction, if you can remember this, is driven by this forward and backwards. It's saying, hey, do I follow the direction that the part was drawn in, or do I go opposite? So in my case, I would need two separate subs. Kind of easily handled, right? I could go in and say, okay, let me grab sub 1, copy, and paste it. I'm going to call it sub 2. All right. So sub 2, I'm going to, at least at the sub level, make it look like it's conventional milling. So I'm going to flip that backwards. All right. So now you see it's going the other way around. There's my little chamfers and all that looks good. All right. Okay. Now in the main, let's go back to my main. I guess I'll have to update the name for sub 1 and sub 2. Oh yeah, didn't really think that through. So the downfall is I would need all of this a second time calling up the separate sub. Yeah, there's no other way around it that I can think of, right? Because if I update the name here, it's going to affect the first one. So I really would need to kind of redo the mark. So you could, in theory, like this, I would say this mechanism works fine as long as knowing it's going to conventional mill on the second set of parts is not an issue to me. I would go ahead. If it was an issue, I probably wouldn't use the mirroring. I would probably do the rotate command, because the rotate would do the same scenario as far as the feature, right? So in that case, if we're going to do a rotate scenario, let's create a new sub. So copy, paste, or new main, shall I say. Main for sub 1, ex2, example 2. So now in this case, I'm not going to really call up these again. Could I? Maybe I could. That's an interesting point. So what if I put the mark after my first offset? So this is where you guys get to kind of see kind of how I work through scenarios like this. So I'm going to cut the mark and I'm going to paste it after that line. Yep, right. I want to paste it after this. I'm not going to do any mirroring, so let us delete that. So cut that out. So now I'm going to do an offset. It's really going to be this same offset. Can be down here, paste, and that's going to be now a negative value, right? -6. So that would get me a new. So right now, if I look at it, I should get all the parts in 2 rows, but I'm not going to have a mirror, right? So the direction on the bottom row is going to be wrong. So let's just take a look at that. So there's 1. If you hit Control M, it'll speed up your simulation. Yep, okay. So we see it there. So I have them, but the chamfer's in the wrong location. So now my thinking is, what if at this stage I rotated the coordinate system? The only thing that's probably going to hurt me is they're going to go the other way, right? So I'd have to actually position to here. Yeah, let's see. Okay, so we're down at our 0. Before we call up our features, I'm going to go in and, oops, I'm going to go transformation. I'm going to do a rotation. I got to do an additive because I don't want to cancel my 0 shift. And I want to spin it 180 degrees. Plus or minus doesn't matter because I'm going a full 180. So that would spin my coordinate system, and then I start to call up all my parts. But if my coordinate system's spun, that means my x plus is the other direction. So if I'm right, there's 1. 100%. Okay. And now we're going to go there. That one's correct, but yeah. So how would I fix that? Well, on this one with only the 4, I could position to the end of the string and let it come back. His scenario is not going to work exactly right because he actually has 4 and 2. So it would hurt him on his part. But if it was somewhat symmetrical, that would be a way around this, right? So if I look at the print, this position would be 12.160. So had that location been, 12.160, and this would be one other way to kind of play with it. Wouldn't work for his scenario. I think the simplest thing for him, if he can deal with the conventional milling, would just be with the mirror the way I did it. Or you just go down and you call up each of them individually and you don't do the repeat command. That's another solution, right? It's a little longer, right? Few more events I would need to do. But there you go. There you have it. So that's kind of how I would start to work through a mechanism of like that, So you get to see how I call up subs, get to see the mirror command, the looping of subs. So all kinds of neat little tricks. So we're going to start to do these little videos. We'll do them a little more as certainly as we get different requests, if I think it's something that you guys would be interested in, we'll make a video. So with that being said, thanks everybody, and I look forward to seeing you guys soon. All right, take it easy.